All right, very quick one. Very quick one. Still today, we want to look at some persons have difficulty when it comes to equations. Now, talking about equations, some of them have difficulty when it comes to the balancing of redox reaction. Yeah, balancing of redox reaction. Now, talking about redox reaction, when you see redox reaction, what comes into your mind? The class is very brief when it comes to Musjaro, very brief, straight to the point without wasting time. Quickly, now this redox reaction, of course, is made of, it's a combination of two reactions, of talking about oxidation and of course reduction. Now, this oxidation and reduction, what do they stand for? What do they mean? Now, because this lecture series is specifically for higher level, those persons that are preparing for higher level examination, it can be in 100 level, it can be 200 level, you are having difficulty when it comes to redox equation. Yeah, this is for you, right? Now, when it comes to oxidation, obviously we want to break it down. Let's take it foundationally first before we begin to look at the rebalancing. Now, balancing of equation can occur in various ways, but the one we're going to be looking at today, balancing of equation using, of course, their charges and all that. Now, both in acidic medium and of course in basic medium. Now, quickly, what are the difference between oxidation and of course reduction? Now, we got to take it out very fast. Now, when we say oxidation, very fast, what is oxidation? Oxidation simply means, number one, when there's a gain of what? Of oxygen. Yeah. When there's a gain of oxygen. And of course, oxidation is when there is also loss of hydrogen, also means oxidation. And of course, oxidation is also regarded as loss of what? Of electrons. So when any chemical reaction that involves the loss of electron, we say that is what? Oxidation. Now, very quickly, talking about oxidation again, and we're going to be dealing with oxidation also is the gain of what? Of electronegative elements. The gain of electronegative elements is what? Is oxidation. So this is quick summary of what oxidation is. Now, reduction rather, is just a quick opposite of what? Of oxidation. Therefore, I can simply say that reduction, very quickly, that reduction is the gain, reduction is the loss of oxygen. Reduction is the loss of oxygen, is the gain of what? Of hydrogen. Then, of course, is the gain of electrons. Then, of course, is the gain of what? Of electropositive elements. So we have to be very careful when we're looking at all these. So remember, our mainstay, our main focus of today's lecture series when it comes to redox equation, I don't want to waste much time about some periphery. Quickly, we have to look at how redox equation are balanced, the balancing of what redox equation. Quickly, now remember that I said just now that redox equation can either be balanced in acidic condition or in what now? In basic condition. Now, if I want to balance in acidic condition, what is the rules, or what are the steps I need to follow? If I want to balance in basic condition, what are the steps I need to follow? Now, quickly, I need to be fast in this very quickly. I have a lot of videos to drop. I'm on fire tonight. I have pH shortcuts on how to get pH. I have lipids metabolism to take. I have protein metabolism. So quickly click the subscribe button so they can get the videos back to back as I drop them. Now look at it now quickly. Now if I have an equation, I will not be wasting your time. If I have an equation, let's bring an equation out for us. For instance, let's say we have NNO4 minus and we have NN2 plus, and they are asking us to balance this equation in acidic condition. Now, what are we going to do first? In this lecture series, one we're taking now is that we want to look at when we have one reactant and we have, of course, one product. Now, there are situations where we have two reactants and two products, so we have to break down the equation, but first we need to take it step by step. So we are having something like this. The first rule that you should follow is make sure that the atoms aside from oxygen are balanced. The atoms aside from oxygen are what? Balanced. So you can check manganese is 1, manganese is 1, so it's balanced, perfect. But look at oxygen, yeah? oxygen here is what? 4. I'm not having any oxygen here. Don't be a fool. Don't come and begin to add oxygen to this place. I believe that you're sensible or not. Don't be an idiot. Now look at it now. What else? What are you going to do in this situation? You come and you say manganese. I'm going to write the equation again to give me Mn2 plus. To balance oxygen, I will add water to the other side. So in this situation, I'm adding water to the product side, yeah? Plus H2O. Now, the amount of water I'm adding is dependent on the number of atoms of oxygen here. So I'm adding 4 atoms of oxygen here, right? Don't pay attention to the charge. 4 atoms of oxygen here. So I'm going to be adding 4 water molecules. So it will not be 4H2O. Now look at it now quickly. Now if I have that with me very fast, I have 4H2O quickly. If you have eyes, I can see. With this water addition in the product side, there's already 8 molecules of water here. 8 molecules of hydrogen rather here. And we're having no atoms of hydrogen. So to balance hydrogen quickly, I need to add manganese. I'm rewriting the equation again because it's our first time of bringing this out. Plus 4 times 2. I'm adding 8H plus. So I'm going to be adding the protons to give me Mn2 plus 4H2O. Now, because I am balancing in acidic condition, now I will look at it and try and check. Are the atoms balanced now? Now let's check it. Manganese, I'm having 1 atom here. I'm having atom here, balanced here. I'm having 4 atoms of oxygen here, and of course, this 4 is affecting both hydrogen and oxygen, so I'm having 4 here also. Now quickly, I'm having 8 hydrogen. 4 times 2 is what? 8. So the atoms are balanced. Then the next thing that we have to do when we are balancing redox equation in this condition is that we need to balance the charges. Let's check out the charge. Now I'm having the oxidation number of everything here is what? Is minus what? 1. While the oxidation number of everything here is what? Is plus what? 8. So minus 1 plus 8. Now why am I saying plus 8? Because some persons will be confused. Oxidation number of an ion is equal to the charge it carries, but because I'm having 8 here, so I have to multiply by what? By 8. So now be minus 1 plus 8. That will give me plus 7 on the reactant side. Now when it gets to the product side, this is plus 2. Oxidation number of a compound, of course, is what? Is 0 plus what? 0. Now plus 2 plus 0, that will give me plus 2. So on the reactant side is plus 7. On this side is what? Plus 2. The charges are not balanced. To balance charge, I need to add electrons. Now, electrons are negatively charged, obviously. So the amount of electrons I'm going to add, I want to make sure that the charges on both sides are what now? Are balanced. Now, the number of electrons, I'm having plus 7 here, I'm having plus 2 here. I'm going to add 5 electrons to the reactant side in the sense that I'm going to be plus 7 minus 5. 5 times minus 1, of course, minus 5 will give me plus 2. So at the end of this reaction, my final balanced equation in acidic condition will now be NNO4 minus plus 8H plus 5E minus to give me Mn2 plus 4H2O. Now, remember, please don't be an idiot that this equation has been balanced under acidic condition. Yes, it's always stated in any examination condition on which condition it wants you to balance the equation. Now, basically, this is balancing under acidic condition. But if you are balancing under basic condition, there is something that I want, it's just a little change. Now, look at it now. If they ask us to balance in basic condition, the same equation, in basic condition, what am I supposed to do? Now, look at it very quickly. I need to bring it out. Now, remember, we started by saying that if you want to balance in basic condition, in acidic condition, first off, atoms to be balanced aside from oxygen, keep oxygen aside. Now, look at it now quickly. Now, if we are having this manganese O4 minus to give me manganese 2 plus, now I need to balance the atoms of oxygen by adding 4 water molecules. Now, why am I adding 4 water molecules? Because I'm having 4 atoms of oxygen here. Then, of course, like we did in acidic condition just now, I'm going to be adding 8 hydrogen ions here. Now, if we get to this place, because we are balancing in basic condition, you have to add OH minus to both sides. Because it's basic condition, we have to add OH minus to both sides. Now, the number of OH minus to be added to both sides is dependent on the number of hydrogen that we are having here. So remember, we are having 8 here. So I'm going to be adding 8 OH to both sides. So at the end of the equation, so we now have something like this now quickly. We now have NNO4 minus plus what? 8H plus what? 8OH minus to give me NN2 plus what? 4H2O plus 4 plus what? Plus 8OH minus. Of course, the side of the board, please, and pardon me. Now look at it now. Remember, if I add hydrogen ion plus OH, of course, you're a chemistry student, you are not a dumbass, plus OH minus, I will have what? H2O. So if I add both of them together, I'll be adding water here. I'll be adding 8 molecules of water here. I believe, of course, you can see what's written down here. Now look at it now. So I will now say NNO4 minus plus 8H2O to give me NN2 plus what? Pardon me, I need to take it down, plus 4H2O plus 8OH minus. Now, there is something that is happening here. We have 4 molecules of water, we have 8 molecules of water here. What is going to happen in this situation? I'm going to remove these 4 molecules of water from this because they are common. So at the end of the equation, of course, you can follow it. At the end of this equation, we now have manganese NNO4 minus plus, remember, I'm not having 4 water molecule here, 4H2O to give me NN2 plus there's no water molecule here anymore, plus what? 8OH minus. Now you can see the answer. Now when you get to this situation, we are not done yet. Of course, what are we supposed to do here? We need to balance the charges to check if the charges are balanced. For now, let's check if the atoms are balanced. We have manganese here is 1, manganese is 1, oxygen is 4, plus this 4, 8, so we are having 8 oxygen. Of course, hydrogen is also 8, we are having 8 here. So the next thing is to balance the charge. So we are having -1 here, and of course we are having 0 here. So on this reactant side is -1, here is +2, then here is minus what? 8. So +2 minus 8, we are having minus what? 6. So I'm having -1 minus 6. So what am I going to add to this side? Or what I'm going to add, number of electrons to add to make it what? Balance. So my final equation, pardon me, I need to write it at the top here, please, sorry. So taking here, my final equation will now be NNO4 minus plus 4H2O plus, remember we said -1 is the total charge in the reactant side. This is what? -6. So for me to make the charges balance, I need to add 5 electrons to reactant side. Why? Because plus 5E minus, so -1 minus 5, you get -6. Yeah, making sense? Making a lot of sense? Yeah. Okay, now let's go. So my equation will now be plus 5E minus to give me what? NN2 plus 8OH minus. Now, if you check this equation and the one we balance under acidic condition, of course, you can definitely see the difference between both of them. So, ladies and gentlemen, boys and girls, this is the first stage of balancing redox equation. Now, we want to look at, in our next lecture series, we have to be looking at how to balance redox equation when the reactants are 2 and when the products are 2. Of course, we need to break it down step by step. There are a lot of videos coming up for pH, of course, for lipids. Thank you very much for watching. I hope this video was of use to you. So Musjaro will catch you in the other side. Thank you very much.